In the upcoming sections, we will be talking about functions in Reason. Functions play a crucial role in functional programming because we are using them as the basic building blocks to structure our code. We already covered functions basics in one of the first sections. Now, we will talk about them in more detail. So, let's get started with the functional expressions in Reason and how to define them. In Reason, functions are first-class values. This means we can use them as any other values in Reason. And since any other value is an expression, functions are also expressions. Let's take a look. This is the functional expression. In other words, it's an expression that calculates a value of a functional type. It takes a single parameter language and returns a body which contains an expression that uses the language identifier. And this parameter is scoped, meaning it can be accessed only in the function. As any expression, a functional expression also has a type. The compiler inferred the type of our function. It's telling us that our function expects a string as an argument and returns another string. As you can see, the functional type is different from other types, such as a list type or a record type. It contains a type of function's arguments and of its result. You might notice that our functional expression is a function without a name. That's right, we don't need to give names to the functions. But can we call such a function? Well, let's try that. We called our unnamed function by passing a string to it, and it worked. The fact that we have an unnamed function doesn't mean we cannot call it. In other words, we don't need an identifier in order to call a function. We just need to wrap it using parentheses and pass it arguments. We can also define this function using the pattern matching syntax. As you can see, the difference is that we are using the fun keyword at the beginning. Then we write the pattern matching syntax with a single case. Finally, we can call it using parentheses again and pass it an argument. We will see usefulness of this syntax later when writing a function which performs pattern matching with more cases. Just remember that these two functions are identical. So far, we've seen a couple of unnamed functions. However, functions with names are much more useful. So let's bind our function to an identifier. We defined the getTitle identifier containing the functional expression. This code is more readable than the unnamed version because we can use the identifier to describe the purpose of the function. Moreover, we can use this identifier to call our function later. In the previous section, where we talked about a list, we defined a recursive function which computes the length of a list. the getLength function expects a list as an argument and performs pattern matching over this list using a switch. Finally, it returns the length of a list, which is an integer. Let's now define this function more concisely using a syntax shorthand. As you can see, this is the syntax using the fun keyword we've seen earlier. Now, we don't need to specify the parameter of our function. And we also don't need to write a switch keyword. We just write the fun keyword instead at the beginning. And this keyword allows us to define our function by pattern matching. However, we need to keep in mind that this syntax shorthand can be used only when we are pattern matching a single argument of the function. This means if our function expects several arguments and they are all pattern matched, we cannot use this syntax. Let's take a look. We wanted to define the compute function expecting two integers and performing pattern matching on them. However, the compiler inferred our function in a way that it expects a tuple of two integers instead. Because when we are using this kind of syntax, we can always pattern match only a single argument. So let's pass the tuple. As you can see, we successfully called our function. However, when we define this function, we wanted to pass it two integers. Well, let's try that. We passed two integers and we got an error. So this function is not doing what we initially wanted. It's accepting tuple instead of two strings. However, it's possible to write this function in a way it accepts two integers using the syntax shorthand. We defined the computeStrings function, which expects two integer arguments. We explicitly specified only the first x parameter, which we are not pattern matching. Only the second parameter is pattern matched. This way, we can use the syntax shorthand and still be able to pass several arguments. However, we can pattern match only one parameter. Moreover, our code is a little bit longer because we need to specify parameters we are not pattern matching.